Okay, the next type of energy that we are going to deal with is called potential energy. Now, the last kind was kinetic energy. Kinetic energy was the energy of motion. The word potential, we hear a lot like, oh, you have so much potential, why don't you ever reach it? Blah, blah, blah. Well, potential means what could happen if the conditions were right, like your potential. Well, in terms of energy, we go back to what we talked about with force in the last chapter. That is, force is measured by taking mass times acceleration. And then we introduced work into the lexicon here. We said that that is defined by force times distance. And we also know that work and energy, based on what we talked about kinetic energy and how we derived kinetic energy, we said that work and energy are technically the same thing because they're both measured in joules, that work is the ability to release energy, or energy is the measurement of work, however you want to look at it. Okay? So an example, if I have an object and hold it up about 2.5 meters high, all I have to do is release it and it starts doing work. It starts forming energy. Now, because this pin is going to go faster and faster and faster until it hits the ground, hitting the ground at that point with the greatest possible velocity it can reach, it's increasing the amount of energy as it goes down. With the total amount of energy that could be performed, the maximum amount of energy that we could get, thinking in terms of kinetic energy, the kinetic energy that we could experience at the bottom can be measured by how far it was above from the surface where it's going to stop. Okay, so we're looking at then force of that rock is now gravitational. And so it's going, the force then, which is mass times acceleration, definition, now becomes mass times gravitational acceleration. And since work is defined as force times distance, that means work is equal to force, which is, in this case, mass times gravitational acceleration times the distance. Or, the distance is the height of where it is in relation to the lowest point. Okay, so the potential work that could be done is also known as the potential energy. And so we use the symbol E sub P or U. The scientists dearly love to use the letter U for potential energy. I don't know. So let's take a look at an example. We want to know how much potential energy does a roller coaster have when a 1,200 kilogram car is on top of a summit. Now what I mean by that is, you know how a lot of roller coasters go up and then down, go up and down. The very top part is called the summit. So let's say the summit is 35 meters high. You got a bunch of people crammed into one of these cars and have a total mass of the car and the people of 1,200 kilograms. Then how much energy, how much potential energy do we have? Well, we're saying again that EP or U is equal to mgh. Well, we know that the mass of the car is 1,200 kilograms. Well, the car and the people together. G is the gravitational acceleration, 9.80 meters per second squared. And in this particular scenario, the height of the car is 35 meters. So all you have to do is punch this into your calculator and round off to 3 sig figs, and you get 4.12 times 10 to the 5th, and the label for energy is the label for work, which is joules. Okay? Very simple process and very simple derivation. So it's not like kinetic energy where we have to jump through a bunch of hoops of mechanics of physics get to our final equation. It's just based on mass times acceleration times distance for our work. Okay? So, your practice problems, we're going to stay out of the book this time because I'm not crazy about the book problems on this. is the list of these five problems here. So they're all involving finding potential energy. The last four deal with a trampoline, and trampolines, if you don't put any extra force behind it, it won't bounce back as high as it did the previous one. So I'm asking you to give me the new height based upon the 90% change. It's going up 90% of the time instead of 100% of the height. And so then you're going to predict the potential energy at each height each time you get off the bounce. Okay? Good luck.